Here we have these diagrams showing four parts of an interaction between some charged particles. In part A, there are two spheres acting on each other with an electrostatic force of F. Then we touch a third sphere to sphere 1, touch sphere 3 to sphere 2, and then remove sphere 3 so that we once again have just spheres 1 and 2, except now a different force, F prime, is being acted on from each sphere. We are to find the ratio of F prime to F. The main idea of this problem is the fact that when two conductors are together, they share equal charge that is evenly split between them. So let's work through this and see what the charges will be for each part of the scenario. The problem tells us that both spheres initially have equal charge, so let's say that each sphere starts with a charge Q. In the second image, we are touching a neutral sphere with essentially no charge to sphere 1. A total charge of Q, then, is shared between them and is split equally, so now both spheres, sphere 1 and 3, each have a charge of Q over 2, 1/2 of Q. In the third image, that sphere, now having a charge of Q over 2, is being touched to sphere 2, which still has a charge of just Q. Q plus Q over 2 is equal to 3Q divided by 2, which is split evenly into 3Q divided by 4 for each of those two spheres. Finally, the two spheres moving away from each other in the end now have charges of Q divided by 2 and 3Q divided by 4. Now we can find the electrostatic force of both F and F prime using Coulomb's law. F, or the force between the two particles initially, can be written as the constant K times both of the charges, which are equal, divided by r squared. And because both charges are equal, it can be simplified down to this, where I've written the two charges as just one charge squared. F prime can be written in a similar way, except instead of just a normal Q for each charge, instead we have Q divided by 2 for one charge, and 3Q divided by 4 for the other charge, since those are the charges that we have in the end. Multiplying the constants together, we end up with a simplified form for this as well, written as 3 over 8 times kq squared divided by r squared. Notice that the kq squared over r squared part of the equation is identical to what we found for f. This means that f prime can be written as 3 over 8 times f, where we've substituted f in for all the unknown values. Let's divide both sides by f to get f prime over f as the problem asks. And doing this, we see that the ratio is 3 over 8, or 0.375.